Hello everybody. Today we'll be going over pH and pOH and when they're applicable to be used in our classroom and on homework and test and everything. So just before we start, it's important to realize that pH is associated with acids and that pOH will be associated with bases when problem solving. I'm going to label acids as red and bases as blue. It doesn't necessarily mean that they belong to those colors. I'm just doing that to be organized. Alright, so the important thing to understand with pH and pOH is if you're given a pH value or if you're given a pOH value, these values can be used to solve for concentrations. Write that down one more time. Concentrations. Obviously, molarity, right? So, if you're given a pH value or a pOH value, you can plug that into a mathematical expression and get the concentration. With that said, you can also use the concentration of an acid or a base, and for this case, an acid to find the pH, and you can use the concentration of a base to find the pOH. And say you are given a pOH value and you want to get in a pH value, all you have to do is 14 minus the pOH value gives you the pH. Say you're given a pH value and you want a pOH, you do 14 minus pOH. Oh, sorry. Say you're given the pH value and you want the pOH value, like I just said, you find 14 minus pH equals pOH. Gets to pH gets to pOH. Alright, so with that said, I'm going to explain a little bit more into it on the next slide. Alright, so as we know from class and in general, pH can be used to solve for the concentration, as well as pOH can be used to solve for the concentration. So let's see, pH can be used to solve for concentration. pOH can be used to solve for concentration. But the question is, how? So you use logs, and the inverse logs and the minus logs. So let's put that, before we get into the math, let's just kind of, write it out. So say you have a pH value and you want to solve for the concentration. All you do is the inverse log, which is 10 to the minus something value, whatever that pH given is. That will equal the concentration. So let's do one out for practice. Let's say you're given a value pH. Oh, that wasn't right. Sorry. pH equals 2.63. So you just plug that into that formula right here that I showed you. Oops, sorry. Right in here. So you plug it in. 10 to the minus 2.63 equals 0.0023 molarity. Alright, so that's just a number. It doesn't really make sense. Well, I'm going to show you something else that can kind of make an understanding from this. Given the pH, we can solve for concentration. Given the concentration, we can also solve for the pH. Now, using the same numbers, I'm going to try to solve for the pH. So say we weren't given this value pH, and we were only given 0.0023, and you were asked to solve, what is the pH for that? If I were you, I'd guys pause this and try to solve it for yourself, and or just follow along. So let's say the concentration given is 0.0023 molarity, and it asks for the pH. You use the formula, minus log insert the molarity, equals pH. So you just do this out. Minus log 0.0023, and look at that, it equals 2.63. Alright, so what did we just do here? Now let's just recoup real quick. If we're given a pH, we can solve for concentration by plugging it into the inverse log, which is 10 to the minus whatever value given. Excuse me. Now say we're given the concentration. We can solve for the pH by plugging that concentration into the negative log and plug in the concentration molarity, and that'll give you the pH. Now, I use pH as an example. This also works identical with pOH. Works identical with pOH. But it depends on what the problem is asking. So now we're going to do a homework problem that's very similar to chapter 15, number 5, on the next slide. Sorry. So this problem shows that it says that water ionizes by the equation H2O liquid H plus aqueous plus OH minus aqueous. Just like we did in the first test with chemical equilibrium, we gotta just create the constant expression for this. So go ahead and do that. Let's do it. It should be KW, which stands for constant of water, H plus multiplied by OH minus. Now, some of you might have done it divided by H2O liquid, but you got to remember, liquids and solids are not in equilibrium. Those are bad. Alright, so we're given this value. We're given this a constant expression, KW equals H plus times OH. And this is what's given. And the problem asks for what is the concentration for an aqueous solution with a pOH 2.97. So let me write that down real quick. Alright, then make a little bit of space right here. I'm going to lift that up. Alright, I'm sorry guys, I made a little mistake here. Let me just quickly fix this. Alright, back on track now. So what is the H plus concentration for an aqueous solution with a pOH that equals 2.97 at 25 degrees Celsius? Now before we get started, there is two ways to solve this problem. I'll go over both ways. I'm going to go over the first way, which is the more professional or old school way first. Alright, so this is an equilibrium as we can see here, and hopefully by now we all know how to solve equilibriums. And since at 25 degrees, the problem states that KW has a value of 1.0 times 10 to the minus 14. So that's what KW is. So what are we solving for? Right there it says the H plus concentration. Alright, so might look like we have two unknowns, but we don't. We're given the pOH of that equals 2.97, and on the couple slides before I showed you guys how to find the concentration given a pH or pOH value. So what do? You do the inverse log of the value given. This equals 0.0, whoops, that was not good, 0.001072. Alright, so now we just got to solve for the unknown. We know the value of KW, and we know the value of OH. We do not know the value of H+. So pretend that's X and just do simple algebra here. KW divided by OH minus equals concentration of A+. Do this out, you should get something like this. So you get 1.0 times 10 to the minus 14 divided by the OH concentration of 0.00107. And according to my calculator, I got 9.3 times 10 to the minus 12 molarity. Alright, one last thing I want to go over today is say you're given a bunch of numbers. You're given a pOH value, you're given a pH value, you're given a concentration of a base and a concentration of an acid. So let's say you got a pOH of like 8.55, you got a pH of 4. Oh, I'm sorry, we got to do that over. You got a pH of 5.45. And you're given a concentration of 0.0023 molarity of HCl, which is an acid. Then you're given a concentration of 0.0018 molarity equals KOH, which is a base. And the question asks you, put these in order of most acidic to basic. So if acidic's the one on the far left, you know it's a pH scale, not a pOH scale. So 1 to 14, right? So what do? Well, if you look at a few slides before, we know, or sorry, if you fast forward the YouTube video before, you know that if you're given a pOH value, you can easily solve for what that value would be in a pH. So let's see, we'll label these 1, 2, 3, 4. Alright, so let's look at 1. How do we figure out the pH value? Simple. 14 minus 8.55 equals 5.45. Number 2. What's the pH of pH 5.45? Well, equals 5.45. Nothing needs to be done there. Now these next ones are a little bit more tricky. We're given a concentration of an acid. Well, we knew from a couple earlier, as I was talking about, if you're given a concentration, you can easily find the pH of the acid or base. So, let's see, minus log. You plug in that concentration, 0.0023. Now, what does that equal? And that equals a value of 2. Whoa, sorry, not used to that. 2.63. And that's the pH value, or is it the pOH value? Well, you see, 0.0023 was associated with HCl, which is an acid. So when we do the negative log of that, it's going to give you the pH value. So then the last one, number 4. You're given a concentration, you want to find the pOH, or you want to find the pOH. Well, let's just see what happens. You plug in the minus log, 0.0018. You plug that into your calculator and you get, I got 2.74. Alright, wow, so that definitely looks like it's pretty acidic, right? But you got to realize that KOH is a base, so that value gives you actually the pOH value. That is the pOH value. And if we look at number 1, we know how to find the pOH value. We know how to find the pH value from the pOH value. You just do simple algebra. 14 minus pOH equals the pH. So what is 14 minus 2.74? 11.26.